this is specifically set up so that you won't see everybody's results, but it will collect them for our use. Oh. Did you set a different setting on this mic? Okay, technical difficulties. Give me a moment. Oh, I know. Okay, all better now. Okay, we only have 31 responses. Are our clickers working? Do I need to go backwards? Okay, sorry, that's bad me. We'll do a do-over. Yeah. That's right. You can't say that you didn't like it. Did I do it again? Darn it. Rob looked at this for me and he missed that too. So just assume that the second one means disagree. Or no, oh, that one is right. Okay, good. Yeah, boy, I must have been half asleep when I did, I did this on Saturday, so give me, but you have the gist of it. I'll know the numbers. Yeah, I did it again. I think I just cut and pasted. This is going to be this way for the whole time. But I appreciate you voting anyway. So I did this for the instructors so that nobody could say that they disagreed. They would have to strongly disagree. That's bad.
Now, before you answer, I want to invite everyone back to the bar. I'll be buying.
And again, you can pick 2 or 4. Thank you all very much. All right. You guys all set?
I don't know. I don't know. I'll make a few comments, then we're going to do a couple of hard mixtures. Then we're going to do Sean's one as second to last, because I don't want to end on a really unpleasant one that I can barely do, and then we'll finish with one I can do.
Sounds good.
And how long have we got left, Mike?
It's 1 o'clock. I think we have until
3, they
3.
said, but
Yeah. I don't know. We'll leave about 10 minutes for any closing
Sure.
remarks. So we have about.
sure. Is this? Yes, it is. Okay, everyone. I believe we're in the last session. We don't have to try hard as presenters anymore because we have your votes in. I've got a couple of clean-up questions that have been put to me that I'm going to try and do. And then we're going to do, I think, 2 or 3 very, very ugly mixtures, and one that we've been handed by Sean, which is, I think, even more ugly. We're going to give that a go. And I would like to try and do this interactively if that's humanly possible now. I'm going to take a bit of a lead from these guys. But if it's looking possible, my wish is that you do them. So I'll just start with the clean-up questions. First of all, I was asked, how does what I'm teaching now relate to the likelihood ratio methods and PopStats? I found myself in the embarrassing position of not actually knowing what PopStats does. I did a quick bit of Googling and that didn't help, but Deborah's helped me. PopStats implements Weir et al. Of 1997. So I'm Al. I've been working on getting the highest number of papers that anyone's ever had where they are Al. So Weir et al. Implements a likelihood ratio using the product rule, and it requires full representation of the alleles. It doesn't handle dropout. So if Deborah and I have got that right, then it takes no account of peak area, no account of subpopulations, and no account of dropout. It's 1997. It actually is a paper that came out of the O.J. Simpson case. So Bruce and I were doing the O.J. Simpson case. Bruce was in LA and I was in England. And Bruce did a calculation overnight in his hotel room. He'd given a statistic for a 3-person mixture in the Bronco automobile. And Judge Ito, Lord bless him, said, would you please do it for a 4-person mixture? And Bruce Weir did that calculation overnight and reported it the next morning. I was in England trying to check him, and it took me, this was new for me, it took me over a week to do. As you might recall, any of you who are old enough, Bruce got the calculation wrong, had to retract and was ridiculed, and retired from forensic science for 2 years. And he's a genius, you know, he's one of the greats of our time. So this is the method we generated to automate the process. Now, what are the lessons out of that O.J. Simpson story? Don't do calculations in your hotel room overnight, and don't give unpeer-reviewed stuff in court. All right, I've kicked myself every time ever since for not actually being in LA next to him, because I'm a little more hardened than he is to court, and I just said, don't do it, right? Anyhow, so it's actually 1995 technology. Yes, please, Steve? Or anyone with comments, most welcome.
I was just saying you can't really refuse if the judge wouldn't.
I know, but you know, you've got to. So how would we, you know, you've got to say something like, Your Honour, I'm just not allowed to do stuff on the fly. And he says, you will. I guess you go, yes, sir, in the end, don't you? So it is, I mean, it's valid technology, but it's ancient. It's 15 years old, and it is product rule, cannot handle dropout, takes no account of peak heights. So if you plug in a clean major minor, it just lets all those combinations happen. Does that answer that question? So I don't know how many of you have 3-person mixtures where there's no possibility of dropout. It's very hard to do. Okay, now, Michael, I have to draw again.
So which one do you want to start?
No,
you
I've got
want
to do
to
one more
okay.
wash-up.
All right. Let me get you a slide here. There you go.
Okay. Are you there? I have had a specific request to try and deal with this type of, push my little button, this type of profile. I didn't really leave myself enough room there. These are called Madonna plots. Anyone want to guess how they got nicknamed Madonna plots? So that's the official UK term for these pictures, Madonna plots. So we have a profile that is an apparent two-person mixture at all loci. And look, can you make that a bit higher? Just stretch that guy up a bit there, right? We've got a pretty nice looking major. He's got a plausible stutter peak next to him, and over here are two minor peaks. How do we interpret this? Well, realistically, this one doesn't stress me. If we make that the victim, I'm pretty confident the true but unknown offender is AB, and I see no reason whatsoever to consider C as an allele here. Now, why do I have any right to say that? If this is a two-person mixture, then the minor's AB. If I put in the C allele, I have to go to a three-person mixture. So I believe that there is some opinion round here that you have to take those stutters and sort of add them in, and I guess add in effectively another contributor. Well, that's not the belief. I'm going to try a little bit of erasure. If I do that, now we have genuine uncertainty where the other minor allele is, and you do need to consider it. Now, I don't believe I can say that any more straightforwardly. That is the meaning of the ISFG 2006 recommendation. I believe that's the meaning of the Swigdam recommendation, but we have people here who can be authoritative, and I certainly believe that's where the scientific consensus lies. Okay, unless there are questions, Michael will now put on the board a very unpleasant-looking mixture. I don't know if I have to erase or not. No, I can go over here.
Okay. So what we have remaining, and I'm going to, on the fly here, would you like about 10 minutes or so at the end to talk? Okay. So we basically have until almost 3 o'clock. So we have a little bit over an hour and 50 minutes or so to go through three mixtures. It's impossible. It's not feasible to go through every single loci for all three of these mixtures. So we're going to pull out certain markers that we'll look at in more detail. Again, we'll try to follow the same format with looking at the mixtures from CPI point of view, random match probability, and the likelihood ratio. So the first mixture we're dealing with here is the one major, one very low minor. So this does look like a two-person mixture. Can we determine if there's a distinct major contribution here? So I think I actually had a couple of clicker questions, but yes, it does look like we have a distinct major. Are there any stochastic issues? Yes. There's here 4 markers in the blue and green channels where we have alleles that are below stochastic threshold. Notice that amylogenin is at 81 RFUs. So it is below stochastic, but can be used in determining if male is present there. So this is a two-person mixture. There is a distinct major, and again, just a quick, it's probably a little bit greater than 10-to-1, actually, just looking at it last night on the fly. So you do have a very distinct contribution. There's several loci with alleles below the stochastic level. So I'll go ahead and go through from a random man not excluded point of view. automatically off the bat, these loci that have alleles that are below the stochastic threshold would be, you would not be able to use those in your statistics. So the next question is, what about the alleles where everything seems to be above stochastic threshold? Well, here's D21. This stutter peak at 29 is not labeled. Notice, though, that the minor alleles between D8 and D7 are falling around 100, 71, 70 RFUs. So the question is, within this stutter peak, is it possible we have the minor contributor? How many would say yes, it's possible? Okay. Is it certain that the minor contributor is there? No, because this stutter peak is well within what you would expect at a peak that's 2,600 RFUs. So in that case, since we can't completely be sure that the minor contributor is represented at D21, this would be a marker that we would omit. CSF, again, 2 alleles, both well above threshold, but the question is my minor contributor there? So it's possible that the minor contributor, may be the residual difference between the 12 and 11, so you have about 100 RFUs left over. Well, if that's the case, you're below stochastic threshold, so there's possibility of a sister allele not being present here. So without that confidence, we would omit this locus. Here at D3, we have 2 alleles that are above stochastic threshold, and we do have a stutter peak here in the 15 position. I think we could use this, but I think with the caveat that we would want to potentially include that stutter peak, just looking at the potential peak height ratio between the 14 and 18 alleles. Does anyone have any comments on that? Sure, Devin?
Against the rules, because if you're going to be willing to attest that that 15 peak could be an allele, therefore you're going to include it, it looks like it's below the stochastic threshold, so then shouldn't you ink the whole locus?
That's a very good question. Actually, Todd and I talked about that. I think, and Todd's response was yes, you would, if you consider that that is a potential contributor allele, and it is below stochastic, then you would ink that locus. So I think this is the situation where, depending upon your validation studies and how comfortable you feel about stutter, and not just relying upon what does ABI tell me to do, because you may find in your validation studies at D3, in your lab with your instrument, with your validation study, and not just what was put on GMapper, the software, then you may find that this could be argued to be stutter. You would include potentially this loci. Otherwise, you would have to make the decision to not allow. Steve?
I have sort of a logic question. Once you're doing the CPI, you're not assuming a number of contributors, but when you've done your initial evaluation of the profile, you are looking at that. If you have decided that the overall profile clearly is a 2-contributor mixture, are you not then entitled to conclude that since that falls within the stutter culture, that is in fact a stutter peak?
Yeah, I think that's part of the, I do agree with you there, that you are making some assumptions. I mean, you can't say clearly that I'm making no assumptions. We all make assumptions when we look at mixtures. And so I think if you properly document that and you make that caveat clear in your analysis in your report, then I think you're safe to go forward. Todd's not so sure.
I mean, I think that kind of goes to what, and I agree with your logic. I mean, that's kind of why we move towards RMP, because you're using those assumptions during your evaluation of the profile. Why not use that during the stats? I mean, if you're using the assumptions, just go with it. But I can't speak for Swigdam or whatever, but having been a part of some of those discussions, I'm not sure that they would say, your interpretation is one thing, your stat is a different thing. If you're choosing a statistic that doesn't make assumptions. It doesn't matter what you did in your interpretation. You should use that in your interpretation, whether or not you're going to include or exclude someone. But if your stat says you're not making assumptions, then I think with CPE you would have to include it. And that's kind of the downside, is you're throwing away that information, but you know, you're choosing to go with that statistical approach where you cannot make the assumptions. So
I would say instead that I've looked at that profile scientifically based on my validation data and concluded that that is effective.
I think it's a good argument.
You know, doesn't this come down fundamentally to that first inspection of the profile? You know, you're going to make a decision. Is this 2-person? Is it 3-person? Are you going to deal with it at all?
Mike, even though if you may stick with the idea that that stutter because you made the assumption it was 2-person, you're still going to include that stutter allele in the calculation, wouldn't you, though, if you're doing a CPI? Because that allele, that stutter allele appears to be, okay, it's smaller than the, never mind.
Okay. Yeah, this is where it's very tricky. So we'll leave that one for debate. If we look at Tho, there's a peak at 199. Again, above stochastic threshold. So is it possible that there's a sister allele that's not part of the 8 or 9 alleles? I would say probably not. So this is potentially a homozygote. So this would be safe for in CPI. Yeah, unless you have the N+4 stutter. So again, that's based upon your validation.
It'd be N+3 stutter.
Yeah.
N+3. Oh, that's right. It is a 9.3.
It's yeah.
But that is a good point to look at if it is in a +4 stutter position. Here's a situation where with the 11 at 194, again, you would have to make that evaluation, but for the most part, you could make the argument that this could be included as part of your stats. TPOX, again, no real clear convincing evidence that the minor contributor is there, so this would be omitted from the statistical calculation. And D18, you have a 20 allele at 190 RFUs, way out there, so this would be fairly safe for CPI stats. So what you're left with in your statistical analysis, again, outside of D3, where there was some potential discussion as to whether or not that should be used, you're left with only 4 loci to use in your statistical calculation. Everything else is either below threshold or you feel that not all minor alleles are present. Now, this is what you should not do. So you would do your stats on those 4 markers, and that's it. You're done. What you shouldn't do is 3 months later, you're told there's a new suspect, and he's 2327 at D2. Well, let's go back and see what the CP is this time with D2 added, because, hey, I see the 2327 there. Once you calculate your CPE, on your evidence, it stays the same. It doesn't change. You could have 1,000 suspects to come in. It's still the same number. So I'm going to turn it over to Todd.
Did we transfer this? Or is it still on live? Sorry, we keep playing with thumb drives. It's all over the place. Kind of going back to your point with this issue at D3, if you're looking at this, kind of expanding what Chris was saying, is if you look at that, and that is a possible third contributor that you're seeing at D3, then that kind of throws everything else off, and you probably can't do stats on, like, I probably wouldn't be doing stats on the minor component at all if there's a potential for a third contributor there. And so, you know, a lot of this is depending on the context of the case. What is the sample? Is this a doorknob? Is it a cigarette butt? Is it underwear? You know, where is this evidence coming from? And do I have a reasonable expectation that this is a 2-person mixture? But for the sake of argument here, assuming I do have, for whatever reason, I have reason to believe this is a two-person mixture, I only went through certain loci. So- But just going through, I can tell you really quick, looking at D8, you've got that 12 allele at 70 RFU, then you've got a potential stutter that would be a potential allele, a 14 and a 15. Kind of the beauty of the 2P rule that kind of gets rid of some of the issue is with the 12, you would just do the 2P with that, which it's basically the 12X, the 12F. It accounts for everything that it might pair with. So it's going to take into account that 13 that's a possible stutter. It's going to take into a 12, 14, a 12, 15, whatever. So it's a way of using that locus without having to really key in on what's going on at that stutter position. It's already kind of compensated for. But going to D21, in this situation, again, this first question you have to ask yourself, do you feel like you at least have partial representation of the minor component? Looking at it, it's not like D21 is like the D7 with that UV degradation where it's kind of dropped lower than everything else for whatever reason. It looks like it's right where, it's staying even with everything. You can look on either side of it, and you see that you've got representation of the minor component. You can look down below it at other loci. It's similar molecular weight. I've got minor representation. I'm going to go with the fact that I feel comfortable that I think the minor component is being at least partially represented here. Now, that partial representation could come in with the 29, which is in the stutter position, or it could be coming in with the 30. And that's pretty much what this is showing here is we would conclude that it's a 29X or a 30X, meaning that part of that 29 peak could be part stutter, and it could be part allele, it could be all allele, not likely. Or it may be just complete stutter, and you've got either a 30-30 or a 30X. So we would go with the 29X and the 30X. And then you have to subtract out the duplicate 2PQ. Does that make sense? That's a good start. Looking at D3, again, I kind of said this before. If for some reason I think that 15 may actually be a true allele, that kind of negates everything here, and we'd probably toss out everything in the minor component. But assuming I've got a good reason to believe this is a two-person stutter or a two-person mixture, and I feel confident that I can make that assumption, then it's just 2PQ. Good grief. So since we're only concerned with the minor component, we would really only look at the 14, 18. So we could get rid of 16, 17. So this would be subtracted out. And so you really are only caring about the 2PQ with 14, 18. Does that make sense? And then at D2, this one was kind of interesting. You look at it, and you've got your big 1726. You've got your 23 that's obviously not stutter. It's a minor component allele. Then you've got the stutter associated with the 26 that's equal height. You also have the 27 that's in the n+4 stutter position, which actually, with how high this is, n+4 does happen. It's pretty rare, but when you do see it, it's usually half or less than the n-4 peak. I don't know if we all agree on that, but that's been my experience that if you have n-4, so let's say you've got your, let me just do a quick little drawing here. So you've got your big peak, you've got your stutter, and then your n+4, if it shows up, is usually about half of your n, so you've got n-4, n+4. So you end up having this kind of effect where the n+4 is about half the height of the n-4. And so you start thinking about this like, well, geez, do I need to think, is this a 23-25? Is it a possible 23-17, 23-26, a 23-27? But it's a two-person mixture. But it's the 23s at 113, so I can call it 2P, and it takes all that into account, and so I can just go that route and not have to worry about n-4, n+4, or anything else. I think that was all I really looked at. Does anybody have any questions with RMP in relation to this mixture? And I realize we just talked about not doing this on the fly, so be nice. Cool. Thanks. I will hand it over to one of these two gentlemen. just really quick while they're doing this, kind of if you want to do a comparison, the RMP could pretty much be calculated every locus in that profile, where I think with CPE it was like 4 loci. So that's, we're starting seeing, when you've got high-level stuff, the RMP and the CPI really don't differ that much. I mean, there's a couple little things where you can get rid of the homozygote overlaps, but it's really the RMP comes into play when you start getting into the low-level minor components or the low-level samples overall. And that's why we went there to begin with, because that's where our world is.
This one, I'm doing.
Todd, I had a quick question for you. I'm over here. Is there a difference between modified RMP and restricted RMP? I'm going to miss that.
Yeah, quick, sorry. Modified refers to making the assumption as to the number of contributors, and then restricted, you're actually looking at peak height. You're taking into account the peak height balance. Do the, is there a peak height balance, kind of mixture balance, things like that.
Thanks.
Thanks.
Okay, I have been asked to do this profile. It was a locus, actually. And this is one from that one you have somewhere in there that's about a 10-to-1. Michael started by saying he had one there and he had this little squiggle here. He said it's something like a 10-to-1. I don't know which one it is, but he'll tell you.
This is FGA.
FGA, and I believe we're allowed to be told the victim in this particular case is a 2122. And I will invent a scenario. This is a high vaginal swab. The victim says she was raped by one man. She has no consensual partners. And we have a person of interest. And I may or may not tell you what that is. And I'm going to write it in here, because I don't actually know, but he's a 25 something. I'll make him a 2521. Just write it backwards for you. And I'm not going to do it. You're going to do it. So I'm going to do a little bit of helping, but you're going to do the whole thing. So HP, and you're going to write something there. HD, you're going to write something there. And cheating is permitted. You're allowed to crib off your neighbour or put your hand up and make Michael or Todd or Chris come down and help you.
Since you're my neighbor, can you do mine?
Todd said he wants to cheat from me. I bet you I'm the most error-prone person in this room. Okay. Look, I might go a bit fast. I've been notorious for putting the answer up before you guys have done it, but let's just see. Have you got V plus POI? Okay, and have you got V plus unknown? Okay, we've actually done quite a bit of the problem already. Okay, LR equals, and a likelihood ratio is a division sum, so I'm going to really help you and put the division bit in. Okay. Now, remember, in the top line, you're allowed to assume the victim and the person of interest are there. So I need you to put in a probability you'd get something like that if they were the true contributors. I'm not going to help you. Those of you who want to race ahead can do the bottom line, but I'm just waiting for you guys to do the top line. Okay, I'm about to write it in. Just say stop. 1. I feel really good about that, guys. Okay, now, well, I feel really good for a couple of reasons. One, you all got it right, and 2, you all felt confident enough to yell it out. In fact, I feel better about that second bit, because, that makes me feel you're really getting this. Now, under the bottom line, we're allowed to assume the victim's there, but we've got to not know who the person of interest is, so we dramatically rub them out. Okay, can you just make a list of possible offenders for me? And you're allowed to use my little cheat notation, which will make it a list of one term. Okay, I'm about to start writing. Please stop me if I'm going too fast. Do we all agree that the true offender has to have the 25 allele? Do we agree that's sufficiently low level that his buddy might have dropped? So the other allele could be anything. So because we're pretending to be British, we'll put in an F. Okay, but you might have used an X. I'm not offended. Okay. Okay, now, without any further help from me at all, can you just turn that whole thing into a pseudo-numerical answer, please? I'll give you maybe just a tad longer. Everyone feeling good? Can I start writing? Okay, so we put in the number, okay, which is 2. How many orders of 25 and F are there? 2. As soon as I put in that 2, I can lose the F. 2F of 25. And that 1 stays on the top line, and there's your answer. Okay, that would actually be quite a valuable locus. I don't know what F of 25 would be, right, but maybe you guys know, let's call it 10%. The likelihood ratio for that locus is 5, right? That's some value.
So that's the 2p rule.
It's the 2p rule. I suspect this answer is entirely identical to Todd's RMP answer. I don't know if he's done this one, but my suspicion is this would be his RMP answer, his restricted RMP answer. So I earlier said I'm quite warm towards it. I'm not an exceptional purist for likelihood ratios. I think Todd and the other people who've developed this have got most of the good out of likelihood ratios and bundled it into RMP. So if you were nervous about... What's that, sorry? I tell you what, the only thing he hasn't got, he told me I shouldn't attribute it to him. It came from someone else first. The only thing, as far as I can see, they haven't got is the formal logical rigor that LRs have and a publication history. As far as I can see, that's where they're lacking, all right? And Todd and I are working on fixing the publication history one. We can't fix the formal logical rigor one. Would you subtract out 25 squared? It's hidden in there. You see 25, okay. You're allowed to do that. Remember I said there's some wasted energy in what I was doing? That's exactly what you've just said. You're permitted to subtract out 25 squared. Yes, sorry, I didn't catch up with you, Brad. I'm not going to go down there unless I have to. But I told you there's a little bit of wastage of information. That bottom line can actually be 2f25 minus f of 25 squared. If you really want to be pedantic, I could do that, but I was trying to walk before we ran, okay? So I actually find that an easy locus, but that's one that I think Michael Coble did something like that too. But I feel that's a viable locus. So. All right, what's next? Do I sit down and someone else go? Or do we do something worse?
Now it gets worse.
Okay, now it gets worse.
Okay.
This is very unfair, actually, because Todd and Michael, and I think Chris, have been up all night preparing, and I was sleeping or pretending to sleep. So they're all hyper-prepared on this, and I'm doing this on the fly.
John, I have one more question.
Yes.
If we change that around and change that to 2 unknowns, so you didn't know that was the locus type, how quickly, how would it change that?
You know, it changes is a really big deal, Brad. Yeah. I can do it. Can I do it with you quietly on a postage stamp somewhere? Oh, you've got to shoot off, I think, so it's maybe some other time, but you change the hypothesis, you change the answer. Big time. Really big time.
Since we're talking about information lost with that last example with FGA, and Dr. Buckland said I would X that, and you got your result. This is the summary of the 3 examples we did this morning. So the example 1 was the major minor, and so with the CPI we got 0.00 people are included, so that's about 1 in 37,000. With the random match probability, 1 in 45,000. So you can see there's information gained there. Example 2 with the 50-50 equal contribution, 1 in 58 for CPI, 1 in 130 for RMP. And with example 3, which was the ugly 50-50, 1 in 1 for CPI. We actually could not do any stats on those 3 loci, and Todd came up with 1 in about 4. And I think Todd, you extrapolated that if you could do RMP on all of the loci, you would come up to about 1 in
250.
1 in 250 with all 15 loci. So that's the summary that someone asked if we would compare.
Yeah, these numbers are only calculated for the loci we looked at in each of those things, so extrapolating out across all 16 would be a little bit different.
Okay, so the next mixture is an ugly one. It's a 3-person mixture. Its title is 1 major and 2 minor. It's mixture number 4, according to the NFSTC nomenclature. And again, we thought what we would do is to sort of look at specific markers here. So if we take a look at the overall profile, it's I think fair to say that we have a mixture. So here we have a clicker question. Without knowing before, without the A priority, without your prior knowledge here, how many contributors would you say are in this mixture if you were just to look at this now? 2, 3, or 4? That's 1, 2, 3, not the number 2, 3, 4. Okay, I think we're getting close. So most people say it's a 3-person mixture. There's a certain percentage, a nice percentage that says that it could be 4. Okay, does anyone want to comment on that? I mean, it's okay. Looking at the mixture overall, do you see a clearly defined major and minor component here? Is there a clearly defined major and minor, yes or no? right. I'm gonna put the clock, you're on the clock. The New York Jets are on the clock. Okay. This is interesting, okay. We have about a 56% split yes and the rest no. This is excellent, so let's get some discussion here. First of all, let's just quickly go through, are there stochastic issues? Well, yes, and a few of the loci, but let's go back here to let me ask, does someone want to propose why they think there's, yes, you can clearly see a major versus the minor contributor, or no? Does someone want to venture out? Steve, thanks.
I'll put my bar. I would be willing to say that for most of the loci, except the very high molecular weight ones, which I would leave out of my stats.
Okay, excellent. Yes, so Steve says that yes, for many of the loci, you probably could pull out a major contributor. Am I summarizing you? But for some of them, no. And I mean, D3 is a good example. That 17 allele, I mean, we have a 14 and an 18 that are fairly within the same very nice peak height ratio there. But that 17 allele there could be a homozygote from a minor contributor. It could be just an extreme peak height imbalance between, the 14 and 17 with an 18. So in that case, we may not have one contributor who's a major, just looking at that one locus. But if you do look at the other loci, in some cases you can pull out one major. Okay, does anyone else have any comments on that?
Did your question say major and minor, though?
For minor
Yeah, that
peaks, that probably makes a lot of difference too, yeah.
I mean, some of us would have picked out a major, but not a major.
But not a major and a minor, that's right. Yeah, because I think later here, can you pull out a minor profile, the entire minor profile, or I should say profiles, can you pull out the minor contributors from the mixture? Yes or no?
Well, before we get to that, just to go back to, is this? Okay. Just to go back to D3 really quick, where you're saying that there's a clear major there. I'm not sure there is a clear major at D3.
No, I think he said you can't.
Okay.
You
sorry,
can't be
yeah,
so sure.
Sorry. So if you can't pull out a clear major at D3, does that put into question of whether or not you really are seeing a clear major at all the other loci? I mean, you've already said before you probably wouldn't pull out a clear major at the larger molecular weight because you feel like things may be dropping out. But if at one of the smallest loci, one of the most sensitive loci, you can't pull out a major, does that put into doubt for you whether you'd be able to pull out a major at the other loci?
Given that that's an isolated case within the low molecular weight loci, I would probably be comfortable in considering that 17 with a homozygote peak, because it doesn't look like they're unrepresented contributors. And that would explain it in terms of definition.
But that 17, the 18 and the 17 by themselves could pair. I mean, that falls within, well, I mean, depending on, within our curve, it's a potential pairing.
That's a pretty low ratio for
It is. Yeah, I mean, the probability of that is low. Yeah. So, all right, I'm just throwing that out there to see what people think.
But again, it does make the point. You have to really consider it carefully, locus by locus, before you decide.
Right. Let me just reset this question here so we can ask. Okay, so do you feel comfortable that you can pull out the entire minor profile from this mixture, or profiles, or minor contributors from this mixture? Yes or no? Okay, we're up around 90, so yeah, so most everyone would say no. So let's take a look at some of these specific loci, and at least from a random man not excluded, yeah, I mean, as Steve said, with this one, this may be difficult to say that there's a clear major. We could certainly say that the minor peaks present are above stochastic threshold. And so if you are confident that all three individuals are there, then you could potentially use this for CPE. Todd, do you have your presentation on? Yeah, Chris, did you want to do any one of these? All right. D2, this is another example here where, again, as Steve said, we should probably look at locus by locus. Some of the larger molecular weight markers, you may not feel fully confident that you can find a clear major versus minor component. Does anyone have any thoughts on this as far as doing CPE on this particular marker? Looks like everything is above stochastic threshold. Two clear major peaks there. So probably okay that everything's represented there. Yeah, the only concern here again is with these stutter peaks. So the stutter at 22 is, again, does this give you pause, as Devin said? If we consider that's a minor allele, it's probably below it's definitely below threshold. It's but definitely less than the 24 peak, which is at 159. So this is the place where you have to draw the line and decide how comfortable you feel.
Mike, what about the peak between the 17 and the potential stutter at 22? Does it pull up? Okay.
Yes. Yes, that's a pull-up, I think, from yeah. Okay, and then, again, here's another one, VWA. So we have what appears to be a major contributor, 17, 18. Another potential contributor we could claim, or at least show at 15, 16, but the 20 peak there. The nice thing about this is that, the stutter peaks are really not a major issue here, and the 20 allele is above stochastic. So in this case, I would probably feel pretty confident or pretty comfortable using it for CPE. Okay. All right, so I'm going to turn this over now to Todd, and then John and Chris can also take a stab. Yes.
Would you use either TPOX or CSF?
So CSF, 2 peaks. We feel that there's 3 individuals here. Based upon the evidence that we've seen, there's probably one good major component here. Are we confident that both of the other contributors are within the 11 and 12? I wouldn't want to risk saying that. So it's uncertain with just this few information. I can't remember what John said, but I wanted to write that down. When you have 5 and 6 alleles, things are, sometimes straightforward. But once you get fewer and fewer alleles, you get 2 or 3 in a 3-person mixture, you know, it becomes extremely difficult. So I would probably not include that one. I don't know what I did, but, okay, and which was what was the other, CSF and?
Teapots.
Oh, yeah, so, well, TPOX, there's already at the 10 peak, there's a 141 RFU, so, or is that, no, this is the, this is a different,
Yeah, that's this.
I'm on the wrong mixture.
It's the
Sorry.
same situation.
Oh, it's the same situation. Okay, yeah, so TPOX, the 156, the 10 allele is above stochastic, but once again, I'm unsure if the remaining minor contributors are, the remaining minor alleles are all within 8. Based upon its TPOX, they probably are, but I wouldn't want to make that conclusion, so I would probably not use this locus.
Before you sit down, I just have a quick question about that. I've heard some people saying that in their labs they would not drop a locus even if they thought maybe the minor contributor had dropped out. And so I just hoped you'd go over the reasoning for dropping that locus.
Well, it comes to, you know, just talking with Todd and others, it comes to the level of comfort, and do you feel that all of your minor alleles are there? Since we're not able to use the 2P or an F type designation with likelihood ratio, we could take that into account. But with CPE, then the question is, do you feel confident, just as Steve said, with some of these higher molecular weight markers, where there's one, you know, really big peak, are you sure that there's not another peak that's at a 7 or an 11 that's dropped out? So,
The question I have is, you're making these determinations without looking at your references, which is fine. But are you also taking into account any investigative information that you have? I mean, say this is an E-cell fraction from a pair of panties where the victim had consensual sex with her husband and then was raped by her brother-in-law, where you would expect overlapping alleles at several loci. I mean, are you taking that into account at all in real life when you're looking at these? Or do you just discount any investigative information you have and just look at it completely blind?
right. Well, for this particular example, we didn't really have a scenario that we are applying here. But yes, you would take that into account in your, I think in the next one, we did make up a scenario. So you'll see what it's not quite the same scenario, but it's something similar. So, so yeah, I mean, you would take that into account, that type of, as to whether especially you can, well, not for CPE, but whether you can condition on individuals.
And I think for the likelihood ratio approach, that's absolutely implicit in the approach itself. You've got to actually set 2 hypotheses. So, you know, have we got a person of interest, victim plus boyfriend plus unknown over victim plus 2 unknowns in this case? Or have we got victim plus 2 unknowns over 3 unknowns? Depends on the circumstances of the case. And it will make a difference to the likelihood ratio number, even if you feel confident enough about actually doing the calculation.
And that goes the same with random match probability. You have to feel comfortable with the assumption you're making. I mean, random match, you know, part of the crux of that is you're making an assumption as the number of contributors. If you're not comfortable with the number of contributors, then you shouldn't be doing random match. You probably shouldn't be doing stats on that, and you know, it makes the whole thing kind of difficult. So, yeah, you definitely take into account. You know, for us, it's more of, you know, hey, this house got burnt. We know he came in the front door, so we swabbed the doorknob, and we've got 6 alleles at every locus. I'm probably not going to feel comfortable that this is just a mixture of 3 people, because who knows how many people touch that. If they say it's a, you know, a cigarette, or, you know, who knows, but I mean, there could be some other circumstance where I'd feel much more comfortable that this is a limited population that could have touched us down to 3 people, then I'd feel better about that.
I've got to go, guys.
Okay. And one of the, kind of the big difference between RMP and RMNE is really, with RMNE, CPI, you have to be confident that all genetic data is represented in what you're seeing. So, you know, if you have two people, A, B, C, and D, you have to be confident that A, B, C, D alleles are all represented there. With RMP, random match probability, you just have to be confident that you have at least partial representation of everybody there. So if you have an AB with a CD, as long as you have like ABC, you know, if you have a minimum of 3 alleles, then you're confident that you have at least partial representation of the two components, and that's what it comes down to. So that's why at the higher limits or the higher RFU levels, there really isn't that much difference between the RMP and the RMNE. But it's when you get down at the lower levels where things start, you know, might start dropping out, that where CPI can't be used. You can still use the RMP because you can use that, you know, under the assumption of however many contributors that you have at least partial representation of all components. Does that make sense? Thank you. All right, sorry, reorient. So looking at 1 major, 2 minors potentially. This is where we kind of drop back and punt. I spent, back when I was, you know, spent the last year and a half or so looking at RMP stuff, and just so people, if you know Stephen Myers, just so you don't think we're totally screwing him on working on this paper, he's actually one of the co-authors. So I learned most of RMP stuff from him, so I'm not going to go write a paper without him. So he's in that, hopefully that publication as well. But when we were looking at this stuff, you know, I spent a long time putting together that Excel worksheet, and you know, part of that time is writing out all the different combinations. I spent the better part of a day or two trying to figure out all the combinations of 3 alleles, or of 3 people, starting with 1 allele, you know, 1 allele being present, 2 alleles being present, 3 alleles, 4 alleles, and then I just dropped back and punted, because there's no way someone's going to sit down and go through 100 different combinations to determine which ones are actually possible. So it really doesn't gain you that much information is what it came down to, and I realize that's kind of a wuss out of how to deal with this. But if we get a 3-person mixture, one, you know, at our lab, we have to be fairly confident it's a 3-person mixture. That's a pretty rare event anyways. We also are going to have pretty good representation of these things. So for the most part at our lab, we only do this comparison and statistical calculation for a 3-person mixture if we have 5 alleles or more. Because at 5 alleles with a 3-person mixture, we're sure that we have at least partial representation of all 3 components. If it's a high enough RFU level, you know, we're in the 500 to 1,000 RFU level across the board, we'll go down to 4 alleles potentially, but you know, beyond that, and there's so many different permutations of that. But for the most part, we look at 5 allele and 6 allele loci with 3-person mixtures. So in this case, D3, we have 5 alleles. We also get away from the whole restricted aspect and we go to unrestricted. So we do an unrestricted RMP, which basically we're doing CPI. So we do D3, we'd use this as a CPI. Since it has 5 alleles, we would still, this is still a modified RMP, so we kind of get into this issue we were talking about before. But since there's 5 alleles, we don't have to worry about subtracting out the homozygotes, because you can still have a homozygote genotype within that. And I don't know if I don't think we hit a 6. Yeah, there's not a 6 allele locus that we're looking at here, but if we had a 6 allele locus, then it's basically the CPI with all the homozygote genotypes subtracted out, and that's the modified part of the RMP. But if it's 5 alleles with RMP and an unrestricted RMP, it's a CPI. But we just don't like saying we're doing RMP on this and then a CPI in that, because you can't really combine those things. So we just call it an unrestricted RMP. Does that make sense? Cool. D2, wow, I wrote a lot. So here we've got that troublesome little 22 thing going on there. You have a peak in a stutter position, it's below stochastic threshold, but since it would be a 6th peak in an assumed 3-person mixture, you have no possible dropout. So if we made the assumption that, wow, you know what, this is a a three-person mixture, and I'm going to go ahead and make that assumption that that allele peak, or that peak at 22 is definitely allele, then you've got all heterozygotes. And so you could do that and you subtract out all your homozygotes. The problem is, I don't feel comfortable that that 22 is definitely a peak. So basically, this is the ultimate wuss out. This is going to be exactly like CPI, where I would take the 17, let's see if I actually put that on there. Basically, I would take the 17, the 22, the 23, 24, 26, and 27, and do basically an unmodified, unrestricted RMP to CPI. So I'm considering all 6 of those as possible alleles in any combination of those 6, including the homozygotes, because if you think there's a possibility that that 22 peak isn't an allele, then that opens up the possibility of homozygotes for the other alleles. Does that make sense?
Todd, I'm going to interrupt real quick. I know a lot of you are going to start leaving here in the next hour or so. Please don't forget to turn in your clickers or you'll be getting a phone call from me.
And just one more quick one. VWA, very similar to before. You've got 5 alleles. Again, all are above stochastic threshold, so at this point we don't have to worry about dropout associated with these things. If you have 5 alleles, if everything is above stochastic threshold, there's no possibility of dropout if you go with the assumption of 3 people. Because if everything's above, that means one of those peaks would have to be shared in order to have a part of that peak being associated with dropout. But if that's the case, then that dropout peak would be a 7th peak. So that, or a 7th, yeah, it ends up being a 7th peak. So you really can't have that in a 3-person mixture. So if you have 7, or if you have 5 peaks in an assumed 3-person mixture and they're all above stochastic, you can't have dropout. So it ends up being basically the RMP is equal to a CPI. And it's very similar to if you have 3 peaks in a 2-person mixture and they're all above stochastic, you can't have dropout associated with any of those.
So if you do that and say one of those alleles, and one of those alleles is below threshold, your stochastic threshold, and you have 5 alleles, then how do you calculate that? Do you just do the 2p for that?
Yeah, you incorporate the 2p associated with that allele.
Do you worry about the homozygotes in that case, or no?
I would do that kind of ultimate wuss out thing where I would include the potential for homozygotes in case there wasn't dropout associated with it. Yeah, we really, what we do with 2-person mixtures, I think we're moving towards using more of the data. We kind of fall back pretty far when we get to 3-person mixtures. That was it for that particular one. It's kind of less crowded up here.
Is this Sean's one?
Like this, D3
Yeah, sure.
or D2.
You just pick them.
Does anyone have would anyone like to see John do one of these 3, D3, D2, or VWA from a likelihood ratio? Does it matter?
Give me Sean's one.
Oh, you want to do that one?
Yeah, come on. I haven't taxed you guys hard enough. Sean one's close to impossible.
It's not as anonymous anymore. Sorry.
Oops. A person formerly known as Sean. I thought we'd picked one of these loci.
Yeah, I was just giving kind of general idea.
Oh, can we go back to this general idea then?
Yeah, so
So 1, 2, 3, 4, 5, 6. So there's 7 peaks, and we've got one big one and a bunch of little ones. And, I'm very comfortable with anyone who feels like closing this case down immediately and not doing it. So, I think we know something about this. Is that right, anonymous Sean? We have an owner of this item or something. Is that correct?
Not exactly. It's a homicide case. A fight broke out between the victim and a bunch of people. Ultimately, the This was a homicide case where the victim got into a fight with a bunch of people in a park, and ultimately the victim was shot. Witnesses at the park say that they saw the shooter wearing a pair of black gloves. When the police showed up, the people in the park vacated the park rather quickly, and along the way of the path that they left the park through, they found a bunch of clothing. One of the pieces of clothing was a pair of black gloves, and this is the DNA result from the inside of those gloves.
Okay, all right. Let's have a go at it. So let's have a look at that locus. So we've observed that we've got at least a 4-person mixture. My first counsel to anyone doing this would be to not do it. Okay, but as I understand it, the deceased at the scene of the crime has bled extensively and is 15-15. So I'm not going to make you do this one because I think this one would destroy your hopes for the future. Okay, but let's just see, do we think we can do that? I don't even know if we can do that, but okay, let's say we've got a deceased at the scene, it's bled profusely, we've got some gloves at the scene, maybe we can live with that. I assume we have a person of interest. I don't know what that is just yet, but let's have a POI. And I think I need at least 2 unknowns, do I? Okay, now, as my second bit of advice, anything with 2 unknowns in the denominator is hard. Anything with 2 in the numerator and 3 in the denominator is very hard. So I'm going to show you just the technology of how to do it, but my advice really would be not to do it. Okay, I hope that sometimes we're just pushing things too far, you know. I had to do some cases for Melbourne, and I took them into someone, and they said it looked like a mama duck with all the little baby ducks walking down behind it, and then, you know. So this looks a little bit like that as well, doesn't it? Okay. What do we think's in this mixture? Well, I think there's 2 15s, aren't there? Not even trying to pair them up or anything. Of the 2 15s, there's at least 1 16, 1 17, 1 18, 1 19. I'm not so sure about a 14. 1, 2, 3, 4, 5, 6. I need 2 more alleles. Okay, and I think in American speak, if I copy Todd, we call this wussing out. Is that right? So the wuss out equivalent is to throw in Fs. If you're not sure, you just throw in Fs. Maybe it looks like that. To be sure, if we're going to do this case, the 3 steps we've just done, the setting up the hypotheses and writing down this list are the hard bits. From here on, it's actually mechanical. Okay, I now reveal mysteriously, Mr. Coble, Dr. Coble, that the person of interest is ... Of course, it becomes a great embarrassment now if it's not in this list anywhere.
Let's say 15, 16.
Okay, we're going to say 15, 16. At least it's in our list. All right, a likelihood ratio is a ratio, so we put in this, and the top line has to have, so we can have the victim and the person of interest, so we've got to have a 17, an 18, a 19, and 1F. Okay, now why 1F? Because I've got a victim who's a 15-15, a person of interest who's a 15-16. I've got the 17, 18, 19. I've now got a tally of 7 alleles, and I've got to get to 8. So I put in 1F. Bottom line, I only got that 15-15 in there, so I've got to account for the 16, the 17, the 18, the 19, and 2 Fs. Just make sure I tally to 8. Just a quick check, who've I lost? Who's following? Who doesn't know how to vote? Okay, that wasn't so bad, actually. This is such a hard case, I'd counsel not doing it. So really all I'm doing is taking the technology out for a walk. Okay, I'm going to crank it through. I've done this so often, I know that top line is 24. You're already just about done it often enough to know that's 24, is that right? F of 17, F of 18, F of 19. The bottom line, it is 360. Who said that? You can have a special sweetie reward, whoever that was. I can't identify you. That is 360. F of 16, F of 17, F of 18, F of 19. We get these beautiful cancellations. What's 24 over 360 is 15, is it? 1 over 15, F of 16. I bet that locus is close to valueless. All right, what's a standard frequency for the 16? I bet 15 times it is very close to 1. So I bet we've just done a lot of work to prove that locus is close to valueless. Anyhow, we took the technology out for a walk. Now, when I first introduced this technology to you, I did really ask you to realize that although you can do it, it doesn't mean you should do it. All right, and I kept borrowing Todd's nice little saying is that you cannot make chicken salad out of chicken dung. So yeah, I can apply the technology to anything, and in this case we've got what I suspect is a valueless answer, and I would counsel not doing it. All right. I notice the class is disappearing. I'll take Michael's lead. I felt really warm about the way you guys waltzed through that slightly easier one before. I really felt you got that, and I feel you could apply the technology, and I do pick up from you you've got the judgment to know when not to. So I feel really good about that. So unless Michael tells me to do anything more, I'll sit down. He's recording all this. He pushes a button, and everything I've written goes into his slide. It's like I can see this coming up in court against me sometime.
No, it'll be on eBay tomorrow, so. Okay, so let's take a little bit of time here, what time we have left. Again, we know that people are trying to catch flights, and so, again, as Debbie said, don't forget, leave your clicker. So the last example we have here is mixture number 3. 2 majors, 1 minor. So looking through the mixture, this is pretty apparent. We have more than 2 people. We have some loci like D3 with 5 alleles, so forth. So using your clicker, how many contributors would you say are in this mixture? 2, 3, or 4? 1 is 2. Okay, since we can probably say we have some attrition, we'll stop here at about 75, maybe. Yes, okay. Anyone else? All right. So yeah, most people agree that it's a 3-person mixture. This is a tricky one here. So do you see a clearly defined major or majors within this mixture, and a clearly defined minor contributor? Yes or no? Okay. No. So there's not a clearly defined major and minor. Just a quick look to see if there are any stochastic issues. Yes, at D7 we have one peak. It's in a stutter position at 91 RFUs. And then in the NED channel we have several peaks that are below our stochastic threshold. So some assumptions about this particular case here. When last night Chris and Todd and I were talking, and John, earlier in the day, let's assume that this is sexual assault evidence from the victim. She had one consensual partner before she was assaulted. So if you take a look at amylogenin, you can see that there's a major XY peak, and so what we're trying to identify here in this, we could assume then the minor contributor, let's say this is the sperm fraction from a differential, we have a very low level minor, which is most likely the victim, and we have two major contributors potentially here. So based upon that information, as far as proceeding with exclusionary statistics, do you feel confident here with D13, with this just an example, that the two major components, maybe we want to do the CPE on the major components, so do you feel confident that the major contributors are represented here? Yeah. And so even with that 13 allele, excluding N+4 stutter, it's well above stochastic threshold. So if this is the victim, she's most likely homozygous here, or there's no little chance of dropout. For D16, again, once you start moving away from the 4, 5, 6 peaks and 3 peaks here, how about this particular marker here at D16? Do you feel confident that the two major contributors are present among these 3 alleles? Brad's shaking his head no. Some people are saying yes. So, yeah, I mean, it's a little tricky on this one. So, do you want to comment, Brad? No? Okay. So, yeah, so it's difficult to say here whether we have a full representation of the two major components in this mixture. So this may be a marker that you would want to consider potentially not using in your stats.
Right?
Yes.
Before I would say that, I would have to look at the peak heights. And even if I can't see where the dropouts would be.
That's true. Yeah, so if you do consider the peak heights, so if you have a 911 and 1111, that makes sense. It's unlikely, I think, that if you have both major contributors as 911s, that's pretty unlikely. So even if you were to pair that 10 peak with either residual there, it does seem a little unlikely. So yeah, that might be worth considering.
I would probably document that in my notes if that was my reasoning, and I would do that.
Right. So as long as you document that and clearly explain what your theory is there, then it could be used. Yeah, this is one that's on the edge. D2, once again, we have everything above stochastic threshold. We have 5 peaks. We do have a little stutter peak there at 22. So What about this one? Do you feel confident that your major contributors are there? Fairly confident. So this would be okay to use for exclusionary stats. And then finally for VWA, again, this is one that I think I would feel pretty confident in using for exclusionary stats. That 16 allele is above threshold. Again, considering there may be a little effect from N-4 stutter and N+4 stutter, since it's between the 15 and 17, it is still above threshold. And so you could take that into consideration too. Okay, so I'll turn this over to Todd.
So we were given the victim's known profile for this, and so since the victim in this case is actually the minor component, the major, I would consider, I would proffer that the major is a mixture of two people. And so once you start going through this, and I'm not showing the other half of this, but just this was the last one I did this morning, so hopefully it's pretty close. But going through, looking at D13, if you look at that, you've got 4 alleles. The minor was a 12, the victim was a 12, 13, so part of that 12 is coming from the 13. So you end up with basically 4, if you just look at the major component, which is a mixture of 2 people, make the assumption that the major component is a mixture of 2 people. All of those compare, so you end up with basically all combinations of those 4 alleles can go together. And so you end up having basically all genotypes of those 4. So it's all the heterozygous genotypes for the combination of those 4. So it's basically the CPI minus the homozygote genotypes. Yes?
If you were provided with a standard from the consensual partner, would you also subtract it out of the peaks that you have?
Yeah.
You would?
Yeah. Yeah. We don't get a lot of consensual partners with guns and bombs, so this doesn't come up a lot.
Would you also tend to use any of the information you might have in your non-sperm fraction as you're going about this? Or are you looking at his sperm fraction?
I haven't done a sexual assault case for about 5 years. I don't know. I haven't even contemplated that with RMP. I mean, it doesn't come up. The only time I do a differential is on proficiency once a year. So that would take some thought when I've had a little bit more sleep. D16, again, the victim here is a 9-10. Looking at the mixture proportions and everything else, I pretty much just scratched out the 10. Basically leaves you the 9-11. I feel confident with the peak heights that are available that both major components, the mixture, the 2-person mixture major is completely represented. I don't think there's any possibility of dropout. Excuse me. So you go through this thing, you end up saying it could be a 9-9, 9-11, or 11-11, and just to go back, I mean, that basically stems from, could be a 9-9 with an 11-11, yeah, a 9-11 with an 11-11. So you end up with those, excuse me, those 3 potential genotypes. Go from there. Excuse me. Oh, thanks. Then D2, losing it. The minor component is the victim is 1726, so now you're left with 3 peaks for the major mixture. Go through the ones that seem to make sense with the mixture components, 23-23 with the 24-27, or the 23-24 with the 23-27. Yeah. And so you end up with those potential genotypes. So this is our way of documenting kind of what we're saying is happening there. Then VWA, I believe, is the last one I looked at. Oh. All right, I did D18 too. Go me. Oh, D18, yeah, sorry. 1214 was the minor in this case. So you take out those two fairly low level. Everything else is above threshold with the two-person mixture. You've got 3 alleles, all above threshold. Things are getting kind of weird down here. So all those were, I've had those as potential yeses for the combinations. So you get all these potential genotypes that are possible contributors in the RMP. And even with all those potential genotypes, you're still at 8% of the population would be included as a potential contributor to that mixture. So, you know, even though you see 1, 2, 3, 4, 5, 6 different genotypes are possible contributors, you're still looking at 8% of the population as a potential contributor. So, that I believe is it.
Okay, well, that pretty much concludes the going through the mixture exercises. Does anyone have any questions or final comments that you'd like to make, or anything that? Yes.
Hi, Mike. The question I have is, like, in reference to your last example that we just showed, if that was not something where you're going to have a forensically valid assumption, what mass ratio would you guys recommend you'd use in order to separate out, like, a restricted CPI for 2 majors? And like, you'd be able to filter out your minor? Like, how much of a difference are you looking at? You know, where people say for 2-person, you're looking at a 4-to-1, but now if you're talking about a 3-person, but you appear to have 2 majors, what type of buffering do you want with that minor?
Well, to be honest, I think in order to answer that question, it probably should do some validation experiments to take some
I knew you were
known
gonna say that.
combinations. Because I don't have the answer off the top of my head. So, but yeah, because there are additive effects, and
Sure.
You know, it's difficult to say a cut and dry. Well, if you're over 3-to-1, you're okay. But yeah, that would probably, in my opinion, I would do some quick little experiments to see what I would feel comfortable with at different DNA inputs too. Hey, Margaret.
If I look at the guidelines and they tell me what statistical methods I can use, it says I can use, you know, NRC, and it quotes those, and or other court-approved methods we've been looking at today. I doubt they're court-approved in my area. They aren't NRC. How does one approach those problems if you want to change your method? I mean, am I learning these only to find out I can't use them?
Yeah, that's. Does anyone in the audience have any advice on that? John?
I think likelihood ratio's got a general sanction in NRC too. Yeah, and
If I use your method instead of the one in Constance, am I okay?
I think it's the same.
I believe so. It's published and I don't know if it's court approved in your state, but it is in mine. But I'm sure, but I guess you may be faced with a Dobert Fry. I'm not sure.
So I would have to guess, to do this, to make this work nicely, we would have to go through all the hearings. I would have to have some expert come in and help me get this report, because I just looked at this.
I'm so getting near the very edge of anything I understand here, but everything I've taught you in the last 3 days comes from basic principles of mathematics and a theorem that was laid down in 1763 and the core principles of molecular biology. So I'd argue I haven't actually taught you anything, right? It's just an amalgam of really ancient theory and modern genetics. Now, if you do have trouble getting it through court, I'm sure we can try and help you. Where is your state? Okay, I've never been to Kentucky, so that would be nice.
Well, I mean, part of the thing is, I mean, it says you can do X, Y, or Z or a court-approved method. It's not saying X, Y, or Z have to be court-approved methods. So, you know, if NRC is recommending likelihood ratio,
or a court-approved method,
right.
that's what it says.
But I think, I mean, likelihood ratios are addressed in there. CPI is addressed in there. RMP, I'd have to look, but
If I use modified one versus what NRC says, you see what I'm going, is that gonna have to go through all the trial, all the laundry, all of this?
any method, it could have to go through that. If, a defense expert, if a defense attorney wants to come up and say, I challenge the way you're doing things, I think any statistical approach could be challenged in court. So I don't think it matters what you're doing. I mean, you could be adding 1 + 1 and someone could challenge it. And, I know one state just had to go through a Daubert hearing on swabbing. So I think now with the NAS and a lot of things that's going out there, all judges are throwing rules out the window and just they're letting the defense challenge anything. So I don't think it matters what you use at this point.
So be prepared, in other words, when you change methods, you're just going to have to do it right.
Yeah, don't do it on the whim and just say we're going to switch to this tomorrow.
Okay, well, I think we'll end on a high note. This is something that I showed during my enhanced techniques, and I didn't have my animations working, so I thought I'd go back. This is the one I stole from Raywick and Heiser, so mixtures from high quality, all above stochastic. That was easy, but when you have low quality DNA with alleles below your stochastic, man, you're winning. So, thank you very much. I think I speak on behalf of all of the instructors, and I'm going to turn it over to Debbie.